I'll thank Christopher for sort of stealing my thunder a little bit, because what I'm going to end up talking about is what Boston University has done on the wired side. So I think that hopefully it'll lead one into the other pretty well. And this is going to be sort of a practical talk, just like the one before it, about dealing with worms and viruses, and in particular Blaster and how we dealt with Blaster last fall. Although sort of config examples and some of the more details I don't have in the talk today, it's in some of the URLs which I've got at the end. I'm Eric Gauthier. I work at Boston University. It's not the University of Boston. We're actually a private university in downtown Boston. To give you some idea of our scale, we've got 17,000 undergraduates and 11,000 graduate students, all with computers and the like. And one of the things that I find is that sometimes we're an enterprise and sometimes we're an ISP. So sometimes our solutions go one way and sometimes they go the other. And sometimes they don't work at all because we're really neither. And as far as this bottom part, I'm just a network engineer. There are a lot of giants in our industry in the audience that talk about solutions that I think at times I wonder if I could have done that. So I'm here to tell you that what I'm going to talk about today is definitely doable by the cogs in the audience, the lowly people who are just sort of average skill. Also want to point out that I'm not a lawyer, which I think a couple other people have done. Some of the things that I'm going to talk about, such as snooping traffic, dumping people off the network, have implications for SLAs and AUPs. Also, we're going to talk about requiring certain levels of certain patch levels and such. That can go against certain contractual obligations you might have. We also sort of mandate that you install certain cleaning software from time to time, and I'm sure that will get some people into trouble. So, as always, talk to your lawyers. Just to give you an idea, BU's just like any other typical network. We're a 3-tiered hierarchical network. We've got a gigabit core, gigabit backbone, and then we run 10 megabit Ethernet to all of our students. So if we've got 12,000 students with 12,000 systems in their dorm rooms, we've got 12,000 10 meg Ethernet ports, which as Christopher pointed out, for worms that are particularly chatty, that can mean a lot of traffic. We also have a variety of network devices, ranging from things that are decades old all the way up to things that are only about 6 months old. So any solution that we need to roll out has to be vendor agnostic. We run into real problems whenever we have to do something that relies on particular features, especially anything that involves trunking. There's a lot of schemes out there for dealing with this that say go flip a VLAN or use 8021X, for example. Our gear, especially our older gear in our dorms, just doesn't support it. So we need infrastructure neutral type of solution. And to give you just a feel for our situation, as those who have been to a university know, there's a particular weekend in the fall where everybody shows up, and it typically starts on a Friday and classes start on Tuesday. So we had 12,000 students showing up with 12,000 computers on Friday. They all needed to be running by Tuesday morning. We've got class work that's online, class schedules that are online, registrations that are online. And we couldn't afford to do what some universities had done, which is just sort of shut their dorms down. To give you an example of our cross-section, about 90% of the machines at least self-identify as Microsoft machines, and it's self-identify about 3/4 of them as being in the sort of post-98 realm, which means 3/4 of the systems that are plugging in our dorms were vulnerable to Blaster. And what we found is when we actually ran them through our system, about 1 out of every 3 computers that plugged into the network, when we scanned them, we found that they were actually vulnerable, if not infected. So that works out to be about 4,000 systems that we had 3 days to clean. That was just not possible if it involved a human intervention. So we really needed a system that was self-help, being cheap, and having no budget to do it and only a couple of weeks to do it. We needed a solution that was free. And we were also willing to accept anything that wasn't a silver bullet. We were really looking for something to make the problem manageable rather than eliminating the problem completely. This is the set of things that we used. A network registration system that I'll talk about in the next couple slides. A shareware vulnerability tool called Nessus to do the scanning. Some wrapper scripts and some free downloads to do the cleaning when we did find infected machines, and as well as sort of 2 later procedural things, which are really more tied to closing the loop for what do we do after the students are there on the network, and then we catch them later being infected. And that has to do with our sort of closing the loop with vulnerability scans later and process of quarantining. The network registration system is really just a MAC address registration system. It's really straightforward. It also means that it's a one-time system. So the first time you plug in, you have to go through the process. After that, you're registered and you don't have to do it again. Unlike, for example, the Cisco solution, which requires their new one, which wants you to put software on hosts and such. This has says no software to install on any hosts. It doesn't really require any protocols in the network, so it's not like an 802.1x system or something that uses SNMP traps to flip VLANs. It just takes advantage of a feature within ISC's DHCP server that allows you to populate MAC addresses and make them known and unknown, and then allocate from separate pools of IPs based on whether the host is known or unknown. In our particular case, every subnet actually is 2 subnets. We have a public set of addresses and a set of 10 net addresses. So when I'm walking through the procedure, I'm going to talk that way, although there's really nothing inherent about the process that requires private addresses. You could do it with a single subnet and 2 separate pools and some clever filtering. But that's not in particular how we did it. In addition, we use multi-view DNS tricks, which probably a lot of you are familiar with, as well as some clever redirecting within an Apache web server. At the very end, probably talk a little bit about what we called quarantining, which is a new state and doesn't really exist in the network registration system per se. It's where we have a host that's registered, so we know about them, we know who owns it, but we go into the DHCP server and remove that state from the DHCP server. So a quarantine host is really a host that the network doesn't know about, but the registration system does. And for some of you who are more curious about our registration system, the usage policy for registration is not so much saying that you're the owner of the machine, but that you take responsibility for the machine's actions. And that's how we get around a lot of, well, Bob registered my machine and it's not really my machine, it's really his machine, but it's her machine, but it's their machine. If you register a system, you're responsible for it. So, as I said, there's a couple of components to the registration system. It uses DNS and DHCP tricks. In our particular case, we have a MySQL backend and an Apache web server. This is a really lame version of our network. The first time a student plugs their machine in, it makes a DHCP server request. The first time, obviously, the server doesn't know their MAC address. So the first time through, the system allocates them an address from our private address pool that's unique for their particular subnet. They then, for example, open up a web browser, type in Yahoo or CNN or whatever, eBay or whatever your favorite website is, and it makes a request to the DNS server. The DNS server is set with multi-views such that when they see requests from these private addresses, it always returns the IP address of our registration system. And that's the way we capture students. It falls down a little bit if there's a device that doesn't have a web browser, but people tend to, when things don't work, open up a web browser in the end. And so we end up dragging them into this web portal. Underneath the web portal is just a name-based virtual server with a redirect. So anything that comes in that's not asking for our network registration page gets redirected to the network registration page, so that even though it's getting requests for things like CNN and eBay and Yahoo and whatever, they do get bounced into our registration page. The registration page talks with our vulnerability server. It tells the vulnerability server, which I'll talk about in a second, is this guy okay to let on the network? One of 2 things happens. The vulnerability server either comes back and says, yeah, sure, this guy looks fine, or no, they don't. And when the no comes back, we try to capture why. what's the vulnerability that this person failed. When they fail, they're sort of stopped at this point. We actually display a page that says you failed for a security reason. This is why. And click here for a self-help tool. And I'll get to the self-help tool at the end. The self-help tool is key for us because once they're sort of trapped in this state, they need to get out of it. And so the process at that point is they download this self-help tool, it runs through their system, it cleans them up, it patches them, it gets them going, brings them back through the same registration process that I just walked through. When they get scanned again, now that they're all patched and clean, they pass the vulnerability test and they can move on their way. At the end, of course, after they're registered, they reboot their machine. They go through this whole process again. They go to the DHCP server. This time they're known because they're registered. They get a valid public address. They do a DNS lookup. That DNS lookup returns the correct IP for whatever it is that they were trying to do, and they go along their way. As I said, there's this process that we call quarantining. So if later on down the line we detect for some reason that a machine got through the registration system or subsequently was infected with something, we can go in and remove their state from the DHCP server when their lease runs out, or if we manually flip their port off and on to force them to re-DHCP. They get nacked for their public address. They get issued a private address. They get brought through the system. The system knows their MAC address already. So this time, instead of bringing them through a registration process, since the MAC address is already known and we flagged it as being quarantined, we display a page that's unique to them. You know, this particular MAC address has Welcha or has Blaster. Again, we bring them to our cleaning tool, they go through and clean, and then at the end of that process, they can be let out. Obviously, this all relies on two tools. One is Nessus, which is a free vulnerability scanner. There are two modes to this. Probably the more common mode is the client-server mode. In this mode, you have a client which you fire up. It's got a configuration file. Typically, you feed it a list of hosts, a subnet range, or a block of addresses, and a list of scans to do. It talks to the server, tells the server to do these scans. Server communicates back with the client gets the results for all of those addresses, and then can do things with it. The problem with this model is we're always scanning one IP in our registration system. So there was a large amount of overhead. We had to fire up the script and read in its config file. It was really bulky, and we found that it was really doing a number on our web server CPU. So we moved to a Nessus scripting language, which had the nice benefit of actually doing the vulnerability scan itself. It fires up, it hits one address, it comes back with a thumb up or thumb down, which is really all we needed. The drawback, though, is it can only do one scan. So in our case, we were stuck last fall with only being able to scan for one particular vulnerability. We looked for Blaster and Blaster 2, or 026 and 039. Our security guys tell us that they're working on a way to do both, to have the advantage of scanning for multiple things as well as not having to run the heavyweight client. This works sort of as I described it before. You go to the website as part of your registration, you click on a URL. It's a CGI that fires off the script. In the client-server model, it calls the server to do a scan. In the scripting language version, the server itself does the scan, and it comes back with a thumb up or thumb down as to whether you're vulnerable or not. If you're not, obviously, you get on the net. If you are vulnerable, then you're brought to a cleaning tool. Now, this tool was actually originally developed for our help desk. It actually was already sitting around as one of the tools in our arsenal when we came along last fall. It was originally designed really for the 2000 XP type machines. It's really a wrapper. So it's just a script, it's an SMS script wrapped around several different things. When you install it, it puts itself into the run once, so that when the machine gets rebooted, it would run again, and it constantly updates itself in terms of where it is in the registry. It runs through a set of checks sequentially. First thing it does is it verifies a minimum set of service packs. So in our particular case, we required that NT be at service pack 5, that Win2K systems be at service pack 2, that XP be at service pack 1, and I don't think we did a service pack check for the 2003 systems that came up. If you failed that, then the script would use wget to download the patch and install it for you. It would check, for example, to make sure that you had certain hotfixes, like the blaster ones. If you didn't have them, it would use wget to install them for you. It would also run in the background. There was a lot of fear within IT that people would just say, screw this and kill it, and then try to register again. Obviously, they wouldn't be able to do that because they would fail our vulnerability test again. So we ran this actually in the background with just a little notice window that says, oh, please wait. We're looking at your system. These things would get installed in the background. Obviously, with service packs, you tend to have to reboot. That was the key with the run ones. When you reboot, runs the tool again. The tool notes that it's past the service pack check part, runs the hotfix. If you have to reboot after a hotfix, it's in the run once, it reboots, puts itself back into the run once, passes those two tests. Then we ran the stinger cleaning tool, so that catches about 20 odd viruses and such. This wasn't a catch-all for everything, but it worked relatively well for the particular things that we were interested in. If we found Welcha, we ran Fix Welcha. And then, as I said, that there's a quarantining process where we would sort of manually dump you off the network. In those cases, there was actually a result email that's sent back to IT to say, this is the system, this is the user, they're all clean. We're working on, instead of sending an email at the end of this process, to having it automatically go to a web page that automatically puts you out of the quarantine and back on the network. That's still sort of being tested right now. There's no sort of technical reason why we can't automatically bring people out of quarantine. It's just we didn't have time in August to implement it. We also pop up some things at the end, which are things like, do you want us to set up Windows Update for you? Oh, by the way, we're a university and we have site licenses for antivirus softwares and such. Do you want us to install those? This is oh, by the way, don't forget that this is all an iterative process. The network registration system's one time. The host plugs in. We catch them, we clean them, they go on their merry way, but if another vulnerability comes out, they're already registered and on the network, so this doesn't completely work. So the way we deal with that is we run daily, twice daily, 3 times daily vulnerability scans, for example, Microsoft vulnerability scans of the network. As we find vulnerable systems, we rerun them with Nessus. We figure if both of these things say you're vulnerable, there's a good chance that you are. If you fail both of those, we dump you back into the quarantine, and that's the process that we use to sort of close the loop post original install. I'm going to quickly just jump through some of the gotchas with this. As I said, this all depends on you having a web browser. So what do I do about my Xbox? That's probably our biggest problem, although VoIP phones and PDAs, depending on whether they have web browsers or not, can be problems. It's a website, be careful. You can inadvertently DOS yourself off the net if you try to redirect all web traffic from a very large network at one little box. And of course, this all relies on DHCP, so you better monitor to make sure that people aren't statically addressing themselves around that. I talked about Nessus. There's a balance between the client-server model and the scripting model. And for those security people in the audience, yes, we're failing to open, meaning you have to be proven to be vulnerable to be prevented from getting on the network. So it's perhaps the opposite of the way a normal security model would work. As far as our patching and cleaning tool, there are many languages that are very hard to detect sometimes what service pack or patch level you're at. We caught lots of people with invalid operating system keys, so they couldn't actually install the service packs. This is obviously invasive. So how did we do? It was 90% effective during the registration process. And when I say 90% effective, we had 400 or so machines that we found after the registration process on the network that were still vulnerable or had some sort of virus on them. So that was 400 down from the 12,000 that came through the registration system. So this effective number is really kind of a low end mark. It's really how effective we were at catching the ones that we thought were vulnerable. Again, we thought only 4,000 would be vulnerable. We caught all but 400 of them. After running those 400 through our quarantining process, we again were 90% effective. There was only about 40 or so that didn't make it out of that somehow passed through the quarantining process. So sort of with this one time registration system and then a one pass-through with quarantining, we've taken 12,000 computers and brought it down to about 40, which is definitely a manageable number. No one ended up being trapped in the system. We didn't really ever catch anyone who sort of couldn't progress. The obvious examples of people who couldn't progress were things like, I have an illegal Windows XP key, I can't install my service pack. We didn't really consider that a trap of the registration system so much as someone trying to do something that's illegal. So take that however you will, whether it was a sort of a success or a failure of the system. Our biggest point was that the infections weren't spreading. When the computers were plugged into the network and came through the registration process and got onto the network, they weren't then vulnerable. So we didn't find an escalating population of machines that was getting worse and worse and worse by the hour. Rather, the machines came in, they were or were not vulnerable, and once they got onto the network, they were fine, and we didn't have to worry about them again. So this also led to the problem being manageable by our security and help desk teams, rather than sort of escalating out of control. So I'd like to thank our own internal security and help desk teams because they really did most of this. Southwestern University for their registration system, and all of you out there who have ever written shareware tools, because I'm standing up here talking about how wonderful the system is that BU developed, even though we didn't actually do anything. We just used all of the tools that you did and we just sort of pasted them together, perhaps in a new way. So really thank all of you for all of the work that you did to make us look good.
Thank you.